Hey guys, good morning. We're going over the angles of polygons. I'm sorry I'm out. But I kind of already talked to you guys about this a little bit last week because we needed to know the interior angles when we were finding the areas of our regular polygons. We're going to go a little bit in depth here, not necessarily focus specifically on regular polygons. We're going to talk about all kinds of polygons. So last week when we were finding the interior, we talked about the diagonals. So if you have a polygon, whether it be triangle, pentagon, hexagon, doesn't matter. You pick one angle, one vertex, and from there, you can create all these other triangles. And based on those triangles, it's going to tell us how many degrees that polygon has. And so if we take a quadrilateral figure of four sides, we're able to get two triangles, which means it's going to have a sum. The angles have a sum of 360. And so if you look further down, that's what this table is kind of guiding us through. We have one triangle is 180 degrees. A quadrilateral creates two triangles, making it 360. Over here, this is going to be specifically for a regular polygon. So a regular polygon is going to be all the sides and all the angles are congruent. If we're wanting to find the interior, so inside angles, I would take that 180 and divide it by 3 because there's 3 vertices. 180 divided by 3 is 60. This is why an equilateral triangle has 60 degrees. If we're wanting to go exterior, so the outside, so if we were to take this angle and extend it, talking about all of those angles. So since you're going all the way around, you're creating a circle. A circle is 360 degrees. So 360 divided by the number of exterior angles, 3, comes out to each one would have a measure of 120 degrees if it's a regular polygon. May not always be a regular polygon. All right, and same thing with a quadrilateral. It's two triangles, so 360. 360 divided by 4, each angle, if it's regular, so it's a square, it's 90 degrees. And then notice on the exterior, we're still looking at that 360 because it's one circle all the way around. 360 divided by 4, same thing, gives you that 90 degrees. If we're looking at a pentagon, we see here we're able to create three triangles. So we're looking at 3 triangles, so 3 times 180 degrees. And that's going to bring us to 540. So sorry for my penmanship right now. If it's a regular polygon, so all the sides are congruent, we're now looking at 540 divided by my total sides of 5, and that comes out to 120 degrees. For the exterior, same thing. It's a circle going around the pentagon, so we're still looking at that 360 degrees divided by my 5 external angles. And if it's regular, so all the sides and angles are congruent, that 360 divided by 5 comes out to 72 degrees. Hexagons are a 6-sided figure. Same thing, we can see we now have a total of 4 triangles. So it's going to be 4 triangles, so that's 4 times 180 degrees. And now we're looking at 720 degrees is our total angle sum. If this hexagon is a regular hexagon, all sides and angles are congruent, then we're looking at 720 degrees divided by 6. And that's 720 degrees divided by 6. It's 120. You know what I just noticed? The pentagon is not 120. It's actually 540 divided by 5, 108. I don't know why I didn't catch that. I'm so sorry. Okay. Double check. I think the rest is good. All right. And then the hexagon for outside, we're looking at 360 because it's still a circle, divided by 6, and that comes out to 60 degrees. And you can continue this process for any type of polygon that you have. And so that's why I just skip here. However many number of sides, n will be a number of sides, and we get our formula. And our formula for finding the sum of the interior angles is going to be whatever your number of sides are. So n is my number of sides, minus 2 times 180 will give you the sum of the interior angles. If it's a regular polygon, then each angle is going to be that n minus 2 times 180 divided by however sides the figure has. For the external, 360 divided by however many number of sides you have. So let's go ahead and apply some of these with some application type problems. Here we have a pentagon. It's not a regular polygon since my angles all have different values, but I can still find the measure of angle M or any measure. So I need to know my sum of my internal angles. So since it's a pentagon, that means we have 5 sides, or you can just count. You have your 5 sides. So that means if I follow my formula, take my number of sides minus 2 times 180, and that comes out to 540. So we have a total sum of 540 degrees. So if I set up my equation, that means I have 540, because that's my total, is going to be equal to all my x's, so 2x plus 3x is 5x, another 3x, so 5x was 3 is 8x, plus another 2x gives me 10x. And then we add our constant, so 142 plus 14 and 14, so that's what, 28 plus 42, let me write this on the side, 142, 14 and 14 is 28. So that's going to be 172. And then from there you can solve for x, and I'll let you do that on your own. Or you can look at my answer key here from the sub to check yourself. All right, the next one here we're looking for the measure of each interior angle. It's a regular pentagon, or you can say an 11agon, and this is on our $1 coin, our Susan B. Anthony $1 coin. So keywords here, it is a regular polygon that has 11 sides, and so we can go ahead and find our measure of each angle by following our formula. So that's going to be our number of sides, which is 11, minus 2. All of this is going to be multiplied by 180 degrees divided by 11. And you just multiply that out, find your answer. Okay. This next one's very similar. You're finding the sum of the interior angles of a nonagon. A nonagon happens to be a 9-sided figure. So this would be 9, this is 9 sides. So 9 minus 2, because that's our formula, times 180, and since it's a regular polygon here, we can also go back, divide by 9. All right, exterior, real quick. Once again, exterior is always going to be that 360. The whole sum here is going to have a value of 360 degrees. I don't want to go too in depth here. You'll notice it's going to look similar to another problem. That's okay. So here we go around, add up all your x values. So that gives us 4x. And then your negative 20, negative 10, 14, 29, and 42, 21. You add all those values up and you get 76. And then from there you solve for x. All right. Good luck. Be nice. Help each other out. I will see you tomorrow.